Hello, it's Miss Huser from 8 Silver, and today I'm going to be going over lesson 11 with you guys. Alright, so today we are talking about on both of the lines. So we're going to start off with a little activity that looks kind of familiar because we've done a number line with a ladybug and ant before, but now this is a little different. So, of course, we're going to start off with what do you notice and wonder. So, just glancing at this, you might notice that the ladybug and ant start on opposite sides. So you could jot that down. Ladybug and ant start on opposite sides. So that's one thing. If we look down here, so they both start here. After 2 seconds, they're getting closer, and then at 4 seconds, it looks like the ant has completely passed the ladybug. So we could write between the 2 seconds and 4 seconds, the ant and ladybug pass each other. So between 2 and 4 seconds, they pass each other. Alright, one other thing you might notice is that after 6 seconds, the ladybug is still going. So we can assume that the ant is moving faster than the ladybug. So ant is faster. Alright, so we could also calculate what rate each of them are moving at. So if you wanted to be more specific, we could do that and figure out what rate each of them are walking at, but just what we have down is good. So now we can go ahead and move on to the next one. So these are different bugs that we're talking about, okay? So a different ant and ladybug are certain distances apart, and they start walking towards each other. Alright, so the graph shows the ladybug's distance from starting point over time, and the labeled point right here, I'm going to go ahead and just label it down here, 2.5, 10, is when the ant and ladybug pass each other. Alright, so it looks like the ladybug is walking this direction, and we don't have the line for the ant, but we know that at this point they cross each other. Alright, so just looking here, we can see that the ladybug starts at 0, and then at the end has traveled 24 centimeters, and it looks like it took the ladybug about 6 seconds. Alright, so the ladybug after 6 seconds has traveled 24 centimeters. Alright, so let's go ahead and look down here and see what they want us to do. So it says the ant is walking at 2 centimeters per second. Alright, so whenever we think of our rate of change or slope, it's always our y over x. So let's look at what our y-axis represents. So our y-axis is representing the distance. So this would be our distance over time. Sorry, that handwriting looks really bad. Oh my gosh. Okay. Alright, so this will then help us understand what the 2 centimeters per second is. So right down here on number 1, it says write an equation representing the relationship between the ant's distance from the ladybug's starting point and the amount of time that has passed. Alright, so we need to write an equation that represents this ant. Well, we know that when we write an equation, that it's usually y equals mx plus b, or it would be y equals kx. Alright, so in the beginning, it says that they are walking, they are different, and they are walking towards each other. So if the Ladybug is starting down here, our ant must be starting somewhere else if they're going to cross paths going the opposite direction. So that means we're going to end up starting on the y-axis somewhere. So we're going to go with this equation here. Alright, so what we can do here is figure out what our slope is, alright, or our rate of change. Well, they told us he's walking 2 centimeters per second. So if I think of y over x, it'd be 2 over 1. So 2 centimeters per second. Sorry. So what we can do is start at this point where we know they intersect. And from there, we can continue to plot points to see where our ant hits the y-axis. Alright, so the ant goes 2 centimeters, so 2 centimeters would be 2 tick marks down, so I'm going to go down 2, and then he goes every 1 second. So if I look here, 2 tick marks equals 1 second, so I'm going to go to the right 2 to plot that point. Alright, now I'm going to continue that pattern, down 2 to the right 2. Down 2 to the right 2. And now I can also do that and backtrack to figure out where the ant starts. So we can go back 2, up 2, back 2, up 2, and then we end up hitting the y-axis right at 15. Because if we were to break this down, we could plot a point that goes through each of these dots. So then our line looks something like that. So since our line hits the y-axis at 15, we can write our equation as y equals a negative 2x, because it's going downwards. So since we're going down, that has to be negative. And then we start at a positive 15. So that would be our equation representing the ant. If you have to go back and get any of that again, feel free to rewind and rewatch any part that you may need to backtrack for. And then it says, if you haven't already, draw a graph of your equation on the same coordinate plane, which we did right there. Alright, so now on our last example or problem here, we have a race. So we have Elena and Jada, and they're racing 100 meters on their bikes. So both of them start at the same time and rode at a constant speed. So constant speed. So they aren't speeding up and slowing down, they're just going at flat speed. So here's a table that gives information about Jada. So this is just representing Jada. Alright, so we're going to label our x and y values here. And so we need to figure out what her constant speed is. Alright, so what we can do is put our y over x. So our y value is 36, and our x value is 6. So 36 divided by 6 gives us 6. Alright, so this would be 6 meters per second. Alright, now let's look at the other row just to make sure. So I'm going to take 54 over 9, and that would equal 6 meters per second. I'm just going to do MPS to stand for that. Alright, so Jada, she is going at a constant rate of 6 meters per second. Alright, so now it wants us to graph this relationship between distance and time for Jada's bike race. So my x-axis is going to represent time, and I need to make sure I can go all the way up to 9. So I'm just going to count by ones on the x-axis. Alright, so I have that written out, so you can pause to write that. And then my y-axis represents the distance, and I have to get all the way up to 54. So I'm just going to count by tens on the y-axis. Alright, so there it is. And so if you need a pause to get this written down, go ahead and do that. Alright, so what's nice about having a table this is my point that I need to plot. I just need to plot those points. So I'm going to do 6, 36. So 6, and then 36 is probably right about there. Alright, then my next point would be 9, 54. So 9, 54. And then now I just need to draw a line starting from the origin. I didn't do too bad there. That's actually pretty good. Alright, so there is our line representing Jada's bike race. Alright, so now it says Elena traveled the entire race at a steady 6 meters per second. On the same set of axes, graph the relationship between the distance and time for Elena's bike race. Well, if they did the exact same distance, and up here we know that Jada rode at a constant speed of 6 meters per minute, or second, my bad. And they just said that Elena did the entire race at 6 meters per second as well. Wouldn't that mean that they just tie? Because if they are, they tied. So they are going at the exact same speed, constant speed, for the exact same distance. So, therefore, they tied. So if I were to graph this, it would be the exact same line. So that's it for today's lesson. Make sure to do the practice problems and have a great rest of your day.